This is a video to show you how to do problem 8.43. We have a random sample of 36 mid-size cars that are tested for fuel consumption. And they have a mean of 26.4 miles per gallon. And this is the sample mean because it's from our 36 cars, with a standard deviation of 2.3 miles per gallon, which is also from those 36 cars, so that is our sample standard deviation. It says find a 99% confidence interval for the population mean. Whoops. So because we have the sample standard deviation, that's how we know we'll be using the formula in which we have to use t. So we have x bar of 26.4, we have s is 2.3, we have n is going to be square root of 36. So we just need t of alpha over 2. So because it's 99%, each of our tails is going to be 1% divided by 2, which is 0.005. And when we use the t distribution, the other thing we have to choose is we have to choose or find degrees of freedom, which is n minus 1. So we need 36 minus 1 is 35. So using our t table, we should get that t is going to be t is going to be 2.724. So constructing our upper bound of the interval will be 26.4 plus 2.724 multiplied by 2.3 over square root of 36. And the bottom portion of the interval will look the same, except that it will be subtracted. So the upper bound is 27.44 and the lower bound is 25.36. So we say we are 99% confident that the mean miles per gallon for all cars of this type is between 25.36 and 27.44. The next part asks us, suppose the confidence interval is too wide. So this distance seems too big. How can the width of this interval be reduced? So how to make width of interval smaller? Well, the only thing that we have for us to be able to choose, we can choose n. So if we make the sample size bigger, then that's going to make sigma over square root of n smaller, and that will make a smaller interval. So choosing a larger sample size will make a smaller interval. The other choice we have is we can choose smaller level of confidence. So having 99% made a bigger t. So if we chose 95% or 90%, those would make t smaller, and then we would have a narrower or smaller interval. So we can make smaller interval if we have less confidence, but then that increases our error, or we can make a smaller interval with a bigger sample size, which wouldn't increase our error.